Okay, in the last video we had just finished finding the volume, 58.6 rad 3 cubic meters. Now we're going to go ahead and find the surface area. So surface area of this is going to be 1/2 PL plus B. Well, we found the area of the base to be 16 rad 3, so we're just going to leave that there. Plus, now the perimeter is going to be 8 plus 8 plus 8. Again, the perimeter is of the base figure, so that's going to be 24. And the slant height's actually given to me as 11.2, and then take 1/2. So we're going to go ahead and evaluate that. We get 24 times 11.2 divided by 2 is going to give me 134.4 plus 16 rad 3. Now I can't really combine those any other way than just like that, so we're going to go ahead and actually just evaluate it here. And if you do that, you should get the surface area to be 162.1. That's going to be square meters. Okay. All right, now we're out of the kind of straightforward. Let's get into the more, I guess, complex, I suppose. Number 8. Classroom globes has a diameter 34. What's the surface area and volume? So for number 8, the diameter is 34. Our radius is going to be just half of that, which is going to be 17. So our radius is 17. We just have to go ahead and evaluate this. We're going to get volume as 4/3 pi 17 cubed, and surface area is going to be 4 pi 17 squared. So just quickly evaluating both of those in terms of pi, we should get this to be 1,156 pi. And that's going to be in square inches. And this one's going to be, again, finding where that third power is going to be really important. So we get that 4,913 times 4 divided by 3. And for that one, we're going to get about 6,550.6 repeating pi. And that's going to be in cubic inches. So there's our two answers. For that one, I was just basically plug it in. Number 9 asked me to do a little bit trickier stuff. The lateral area of a cone is equal to 120 pi. So 120 pi is equal to the lateral area of a cone. So you got to look at your surface area formula, and it's that first part, pi RL. Okay, pi RL. And it says the radius is equal to 8. So we can actually go back and say, okay, instead of r, we're going to put in 8. I know that's what it's equal to. And then it says find the surface area of the cone. Okay. Well, first I need to find L before I can actually do that. Or if I actually take the surface area formula and just take a look, this is pi RL plus pi r squared. Well, if I know pi RL is this piece, I can go ahead and just say, well, I already have that. That's 120 pi. Just got to plug in 8 for this. That's going to become, not 16, sorry, 64 pi. So it's 64 pi plus 120 pi. Add this together and I get 184 pi, and I'm done. Okay, so that was actually easier than I originally had thought. I forgot about that one. All right, number 10. Cruising along here, if the volume of a sphere is equal to 972 pi, what's the surface area? So this is one I was thinking more along the lines of 972 pi. That is given to me as my volume, so we're going to set it equal to the volume. Okay. The first thing I do is I can get rid of the pi's. Divide the pi's out, they're kind of pretty much gone on both sides. To get rid of 4/3, I actually have to multiply by the reciprocal, and that would cancel that out. Multiply this by the reciprocal. I like to multiply 972 by 3 first, and then divide it by 4. And so that gives me 729 equals r cubed. Take the cube root, got to find that in your calculator, and you get 9 equals r. Okay, is that my answer? Not quite. I want to find the surface area now, so I basically go ahead and take the surface area, which is 4 pi r squared, plug in 9 squared, pi and 4, and I'm going to leave this in terms of pi, and so basically I just have to square 9 and multiply by 4, and I get 324 pi as my answer. Okay, let's move on to the next question, number 11. Cruising through this page. The surface area of a cylinder and the radius, solve for the height. Okay, so we got the surface area is 552 pi is the surface area of a cylinder. So we're going to write down the surface area formula of a cylinder, which is 2 pi r times h plus 2 pi r squared. Okay, and then it says my radius is equal to 12, so I can actually go back in here and say, you know what, the radius is 12, so let's write that in there instead. 12 and 12, and now let's go evaluate. This first part's going to be 24 pi times height. This is going to be 12 squared, which is 144 times 2, which is going to give me 288 pi. Notice I always put the number in front of pi. This equals 552 pi. Now I want to get h alone, so I got to get rid of what's adding first and then get rid of what's multiplying. So I'm going to subtract 288 pi to both sides. Okay, so 552 minus 288 is going to be 264 pi equals 24 pi times h. So divide by 24 pi, and we're going to get 264 divided by 24. The pi's are going to cancel out, and we're going to get the height equals 11. Okay, which is appropriate for question number 11. The height actually equals 11. Isn't that cool? Super cool. Okay, move on. I'm thinking we're going to have to do 3 parts. This is going to be a long one. Erica made 2 candles in the shape of cylinders. The first candle has a radius of 10 and a height of 18. The second has a candle 9 centimeters higher, about the same radius. How much additional wax is needed to make the taller candle? Alright, well, it says how much wax is needed to make the taller candle. So if you think about it, I got to talk about volume. So I'm really going to be looking at the volume. So I have 2 candles. So we'll call this candle 1 and candle 2. This is going to be kind of like the small one. This will be, I guess, the large one. Sorry, my pictures are bad. And we got to take a look at the volume. Okay, and let's see what's going to happen here. It says the first candle, radius 10, height is 18. So when we're talking about volume here, we're going to get pi. So like I was saying, volume of the first one, the volume of a cylinder is pi r squared times height. Okay, so we got pi r squared times height. Again, so the radius of the first one is 10, and the height is 18. And then the next one, it says the candle is 9 centimeters taller, so I got to add 9 to the height. So that's going to be pi, but it has the same radius. So it's the same radius of 10, but instead of 18, I'm going to add 9 to it, get 27. So there's the difference right there between the two. So let's go ahead and evaluate them. I'm going to leave it again in terms of pi. So we're going to get 10 squared times 18. If you haven't figured that one out, that's going to be 1800 pi. Okay, and then over here, this one's going to be basically 2700 pi. And we want to know how much additional wax is needed. And so we basically are going to take the larger one and subtract the smaller one to find out that answer, and the answer is going to be 900 pi. Alright, number 8, we're just actually finding the surface area of a soccer ball. Number 13. So for number 13, we're just finding the surface area of a soccer ball. The diameter is 36, so the radius is going to be 18. So the surface area is pretty simple. It's 4 pi r squared. So we're going to get 4 pi 18 squared. So my total surface area, again, notice I've been leaving everything in terms of pi. So we get 1296 pi. Okay, so that looks good. But it says about 1/4. So this is my surface area total. It says 1/4 of the ball is black. What is the area of the black part, and what's the area of the white part? So to do this, we get 1296 pi, and I'm going to take 1/4 of that, and then I'm going to take 3/4 of that, and this should give me the amount for black that's on there and the amount for white. Okay, and so I'm going to leave it in terms of pi, so I'm actually just going to take 1296 and divide it by 4. and so I get 324 pi. That's the amount that's covered in black on the soccer ball. And then the other one, we're going to divide it by 4, but then multiply it by 3, and I should get 972 pi for the white portion of the soccer ball. And if you add those two together, we should get 1296, because that should be the total amount. Alright, 14. This one's pretty difficult. We have two parts. Okay, so two parts here. We have a cone, and we have a cylinder. Okay, we need to find the surface area of both. Okay, so surface area of a cone and the surface area of a cylinder. Alright, so the cone is going to be pi RL plus pi R squared, and then the cylinder is going to be 2 pi RH plus 2 pi R squared. Okay, so the radius of this is going to be 10. That's half of that 20. And the height is going to be 6. That's all we need to know there. Then the other one, we got to do a little bit of math, though. Basically, if you kind of look at the picture appropriately, you're going to take about 6 from 20, which gives you 14, and then take half of that. So the radius here is 7. And the slant height, which they give us, is 8. Okay, so we have all the information we need to know, so let's go ahead and plug it in. So we're going to get pi 7 times 8 plus pi 7 squared. Over here we're going to get 2 pi 10 times 6 plus 2 pi 10 squared. Alright, let's go ahead and evaluate those. 7 times 8 is going to be 56. 56 pi. That's going to be 49 pi. So add those two together, and we get 105 pi. Over here, we're going to get 2 times 10 times 6. That's going to be 120 pi. I can do that one in my head. And then this is going to be 200 pi. 10 squared is 100 times 2. So we get 320 pi. And we're going to want to add those two together. And if we add them together, we're going to get 425 pi. But we haven't taken into account any overlap. Now, if you look at the picture, the bottom of the circle actually overlaps. And the bottom of the circle, the area of the bottom of that circle, is actually right here. We found it. This represents the bottom of that circle. Right here, 49 pi. And so I counted it once on here, and I counted it once on here, so I have to subtract it twice. I got to take 425, and I got to subtract pi, sorry. And I got to subtract 2 times 49 pi to get the appropriate answer. And what happens when I get 425 minus 2 times 49 is going to be 327. Whoops, didn't write that correctly. 327 pi. Okay, and there it is. Alright, and last one, we'll be able to get to this last one, number 15, and then we'll probably have to go to part 3, huh? It says the prisms below are similar. Find the scale factor, surface area ratio, volume ratio of the larger prism to the smaller prism. Okay, so just taking a look at this, we have basically a side length, and we have height. Okay, so I have a side length of 18 to 27, and I have 4, whoops, didn't mean to move that, and I have a 4 to 6. Okay, so these should be proportionate to each other, so if I fully reduce these fractions, I should get my scale factor essentially. Okay, I can either compare them to one another, so let's do that. Okay, so I'm going to go from small to large here, and we're going to get 4 to 18, and we're going to get 6 to 27. And just by looking at these, we can go ahead and break them down. But this, we're not going to make it through this full question, so we'll get to it in the next video. All right.